Find the inverse of the functions. All right, so we're looking at example A here, and so with f of x being equal to 2x minus 5 over x plus 4, the best way to find the inverse here is probably to use the approach where we swap out f of x for y, and then we say 2x minus 5 over x plus 4, and then we go ahead and switch the x and y positions, meaning that we'll have x is equal to 2y minus 5 over y plus 4, and then solve for y. All right, so to solve for y here, we might want to, for example, cross multiply initially. So we'll have x times y plus 4 is equal to 2y minus 5. And then we'd want to distribute in the x. So we'll have x times y plus 4x, right? So x times y and then 4x is equal to 2y minus 5. Then we want to get the y's together. So we're going to move the 4x to the other side, and we're going to move the 2y to this side. So we'll have xy minus 2y, right? When it comes over, it'll become negative. The 4x will go to the other side, making it negative 4x and then minus 5. And then from here, we can factor out a y, which is common to both of those first terms. So we factor out a y, we get x minus 2 is equal to negative 4x minus 5. And then lastly, we can divide both sides by x minus 2. And that will end up giving us the idea that y is equal to negative 4x minus 5 over x minus 2. But remember, y is really what? F inverse of x. So this is the answer for our inverse function. You can check to make sure that that is indeed correct, but what you would want to do to check in this particular case is probably do the composite functions. Do f of g, see if it gives you x, then do g of f, make sure that gives you x. If it does, then you found the inverse function. I'll leave that up to you to do. All right, let's look at example B then. We have f of x is equal to x squared minus 9 over 2x squared, and it says that x must be greater than 0. So they've gone ahead and restricted the domain for us here to ensure that the function has an inverse. All right, so let's go ahead and find the inverse then using that procedure we used before. We'll replace f of x with y, and then we have x squared minus 9 over 2x squared. Then we want to take the step of converting that into an equation where the x's and the y's are switched. So we're going to have x is equal to y squared minus 9 over 2y squared. And then we try to solve this function by perhaps performing cross multiplication initially. So we'd end up having 2y squared times x is equal to y squared minus 9, correct? All right, and once we have that, we're thinking about getting the y's alone. So we'd want to bring maybe the y's together here onto the other side of the equation. So we'll have 2y squared x minus y squared is equal to negative 9. And then we can factor out the y squared that's common to both of those terms. So we pull out the y squared and we have 2x minus 1, right, is equal to negative 9. And then from there we want to divide both sides by 2x minus 1. So 2x minus 1 divided into that piece, and that will eliminate it from the left-hand side. All right, from here now, what you'd want to do to solve for y is to take the square root of both sides. Now normally you have to do plus or minus the square root of minus 9 over 2x minus 1, but we don't have to worry about the plus or minus here because remember, we restricted the original x to being greater than 0. And remember what this y was. This y used to be x. We just swapped its symbol to help us solve for the inverse, right? So really that y is really like our old x, and our old x was always greater than 0. So there's no way that when we had it as y squared, the reason why we do a plus or minus is because we never know if this was a negative number in here and we squared it and then got a positive after the fact. But we know going in that it was greater than 0, so we don't have to worry about that. So essentially what we're going to do is to say we can ignore the negative answer here. So we just have to worry about the positive answer for that reason. Okay, now from there, the only other thing we might want to do is to clean this up a little bit. And I think the answer is fine the way it is, except for the fact that probably stylistically it would look a little better if we did something like this. I can bring that negative down below, so I could end up saying, like for example, negative 9 over 2x minus 1 under the square root, right? And then from there, I'm allowed to kind of distribute this negative into that binomial in the bottom. It'll be exactly the same answer, but if you do negative 1 times 2x, you get negative 2x, and negative 1 times 1 gives you positive 1. And the reason why that's helpful is then I can go ahead and rewrite y as being equal to 9 over 1 minus 2x, which just looks a little bit cleaner, right? And then from there, I can take the square root of the top separately and the bottom separately. And we end up with 3 over the square root of 1 minus 2x. All right, so if I wanted to rationalize that, I could also do that. I can multiply top and bottom by 1 minus 2x under the radical, right? Square root of 1 minus 2x. And if I do that to the top and bottom, I'd finally get this as an answer. Y is equal to 3 times the square root of 1 minus 2x over 1 minus 2x, right? Because these radicals would basically cancel each other out. We just have what's underneath it, right? The 1 minus 2x. All right, so that would be your inverse function. That would be your f of x inverse. And again, if you wanted to confirm that, you could do the composite functions and confirm that both f of g and g of f, or in other words, f of f inverse and f inverse of f, both give you x as a result.